Hi everyone, sorry I couldn't be there today. I had to be out for today. But just because I'm gone doesn't mean we're not going to get to work. So I'm going to make this video, and it's my hope that you guys will follow along with the notes. And then once we're done, I'll ask the sub to hand out the homework, or you guys can get to work on your book assignment. And then you'll be done for the day. So what we are doing today is we are applying the distributive property. If you remember the distributive property, we used to draw these boxes when we talked about them before. They looked kind of like this rectangle that we're going to draw right here. But we drew a box and we had maybe a number out here and x plus 2 or something up there. And we used the distributive property to figure out what those were. So first we are going to look at these rectangles here. We're going to find the perimeter and the area of both these rectangles. Now, when we are looking for perimeter, or P, we're adding all the sides. So we're adding all the sides of these rectangles. So we know that this side is 3. We know that this side is x, and then we have an addition here, x plus 4. So what we're going to do is we need to add a couple more sides. This side is similar to this side, so we know that this is going to be x. This side is similar to here, so we know that this side is going to be 4. And we know that this side here is similar to this, so that's going to be 3. So we're just looking at the outside, the perimeter of the entire rectangle. So we're going to add 3 plus x plus 4 plus 3 plus x plus 4. I think we got all our sides. 3, x, 4, 3, x, 4. Yep. So now we need to do what's called combining like terms. So we need to look and see if we have 2 of the same variable. And we do. We have 2 of the same x's. So we can combine those two. X plus x, that's going to give us 2x. And now we look for our other terms, the ones without the variable. So we have 3 and 4 and 3 and 4. Well, if I do 3 plus 4, that's 7. 3 plus 4, that's another 7. If I add them all up, it's 2x plus 14. So 2x plus 14 is going to be our P, or our perimeter. Now when we're looking for area, area is a little bit different. We're using multiplication instead of addition for area. So area is usually described as length times width, or sometimes people say base times height. Now what we have on this rectangle here is our length, or our width, sorry, this is our width, is 3. And we're multiplying that by our length, or our base. So here we have an x, and we also add on 4 to this. So we have to add 4. Now another way to write that is 3 times x plus 4. Now this is where we use our box. So we have 3 outside of our parentheses, and inside is x plus 4. So we're going to draw our box. On the outside goes our 3. On the top here we'll put x plus 4. And then we just multiply. 3 times x, that's going to give us 3x. And 3 times 4, that's going to give us 12. Now because it's positive 3 times 4, I'm going to put a plus 12. So our answer then would be area is 3x plus 12. Let's look at this second rectangle. First of all, we're going to look for our perimeter. So we're going to add up all our sides. We have x plus 7 plus 6x. Now we don't know our other sides, but we can easily find them. This side is similar to this side, so that's going to be another 6x. This side is similar to x, and this side is similar to 7. We have another x, 7, and 6x. So we have x plus 7 plus 6x again. Now, if we look for our like terms, I see we have an x here, and an x here, and an x here, and an x here. Now, how many x's do we have? Well, we have 1 here, 6 here, so 1 plus 6 is 7x. We also have an x here, so that's 1x, and 6 more x's, so that's also 7x. And if we add those two together, we get 14x. Our other like terms are these 7's. 7 plus 7 is going to give us 14. So our perimeter is 14x plus 14. Now our area is going to be base times height, or length times width. And our length will be x plus 7. And our width, or our height, is going to be 6x. So we got to draw our box. And we get 6x outside and x plus 7 on top. Now if we are multiplying these, here we have 6x times what's actually 1x. So 6 times 1, that's 6. But now we have x times x. So basically it's saying we're doing x times x, which if we wanted to simplify that, it would just look like x squared. And 6x times 7, that's going to give us 42x. So our area then comes out to be 6x squared plus 42x. Okay, moving on, we can use the distributive property to write an equivalent expression by using our boxes. So we have 4 and y plus 3. 4 times y is 4y. 4 times 3 is 12. So our equivalent expression looks like 4y plus, we put plus because the 12 is positive, 12. 4y plus 12. The next one, our y is on the outside, so it doesn't really matter where we put the y. For this one, let's try putting the y out here. So we have y plus 7 on top. Y times y, that's going to give us y squared. And y times 7 is 7y. So our new expression will look like y squared plus 7y. Remember to add the y on when you're multiplying a y by some other single number. Okay, now we're going to draw our own box. And on top we're going to have 2 minus n and an 8 out front. 8 times 2, well, that's 16. 8 times negative n, this negative comes with it. So if this is like actually negative 1n, so 8 times negative 1n gives us negative 8n. But we just need to write it 16 minus 8n. Last one on this slide. Draw another box. We got n out front and n minus 9 on top. N times n, that's 2n, so we have n squared. And n times negative 9 gives us negative 9n. So our new answer comes out n squared minus 9n. Alright, let's go to this next one. So here we have a negative sign out front. When we just have a negative sign out front, that's like saying that there's an imaginary 1 out there. So if we drew our box, instead of just a negative sign out front, we could put a negative 1. If we have 2x minus 11, negative 1 times 2x is negative 2x. And negative 1 times negative 11. Two negatives here make a positive. 1 times 11 is 11. So we get negative 2x plus 11. Here it gets a little bit more tricky. We bring fractions into it. But lucky for you guys, it's an easy fraction. So our fraction is 1/2. And 2n plus 6 on top. So basically what this is saying, if we multiply either of these numbers by 1/2, we're basically just saying multiply each number by half, or find half of each number. So what is half of 2n? Well, that's just 1n. Half of 2 is 1. What about half of 6? Well, that's 3. So our new expression is 1n plus 3. Or, if you wanted to, you could just write n plus 3. Either way is fine. The n plus 3 looks the best. Here, this one looks a little bit different. We see two sets of parentheses, but only one has a problem in it. The other one just has a single number with a variable. So we're still going to draw our box because we're still distributing. Out in front, though, we're going to have a negative 3m. On top is going to be m minus 5. So let's imagine that there's a 1 in front of our m here. So first of all, we're going to look at the coefficients, or the ones in front. Negative 3 times 1 is negative 3. M times m is m squared. And negative 3m times negative 5. Well, negative 3 times negative 5. Two negatives make a positive. 3 times 5 is 15. And we're going to add our m. So our new expression is going to be negative 3m squared plus 15m. And I think we're just going to skip this one because I think you guys get the idea now. So we're going to move on to our next slide. So what we're looking at now are the parts of an expression. So this is kind of a review. We talked about this last year. We're looking for the parts of an expression. There are multiple parts. The parts of the expression that are added together are called terms. So anything that's added together in an expression are called terms. So any part of the expression. The number part of the term, so the number part, that's the important part there, of a term with a variable part is called the coefficient. So if you look here, the coefficients it says are -1 and 2, because we could put a -1 in front of this x. This is the number part in front of the variable. The variable, remember, are our letters. So our letters, which are the x's. We don't have any other letters for this one, just x's. A constant term has a number part but no variable part. So it has a number part like this 8, but this 8 is all by itself. So that's our constant. It never changes. Like terms are terms that have the same variable parts, such as -x and 2x in the expression above. Constant terms, if we were to add maybe a +3 to this problem, our like terms for constants would be 8 and 3, and that would come out as 11 if we added those together. So if we look at our expression here and identify the terms, the like terms, coefficients, and constant terms, well, we can look first of all for the terms. Now the terms are everything that's being added together. So the terms are every part of our problem. So we have 5xy. We have a -3. We have a 2xy. And we have a 10xy. Those are all the parts of our problem. Those are all our terms. Second thing we're looking for is our coefficients. Now, if you remember back to the last slide, our coefficients were the numbers in front of our letters. So our coefficients are going to be 5, 2, and 10. I skipped over like terms, so let's go back to that one. Now our like terms are going to be everything with the same ending. So I see that we have a couple or a few with the ending xy. So those will be our like terms. So we have 5xy. We have 2xy. And we have 10xy. The 3 is not part of our like terms because it doesn't have the xy on it. The last thing we need are our constants, or our numbers without letters. And our numbers without letters are just our -3. That's our only constants in this expression. If we go down to our next one, let's identify our terms first. Our terms, it looks like we have a -8, a -x, 5, and an 11x. Now our like terms are everything that look alike. So let's first look for our x's. We have negative x, and we have another one, 11x. I think we have another set of like terms. We have a negative 8 and a 5, because they both don't have variables on them. So negative 8 and 5. Then comes our coefficients. I'm going to shorten this up. It's a long word. Our coefficients are the numbers in front of the variables. Looks like we got an 11. And if there's nothing in front of our x, we can put a 1 there. So we have a negative 1. Lastly, we're looking for our constants, or our numbers without letters. Oh. And our numbers without letters are negative 8 and 5. Alright, so our next slide, we're just simplifying each expression. This one, it looks like we have 2 y's, a 5y, and a negative 14y. We can simplify those by adding plus 5y, or a positive 5y, to our negative 14y, which would give us a negative 9y. Here it looks like we need to do our distributive property. So we need to draw our box, because we have a number outside of our parentheses. We're going to put negative 1 and x plus 7. Now we are left with this 11x, so what I'm going to do is I'm going to draw a little dotted box here. And I'm just going to stick that 11x in there. So if we do negative 1 times x, we get negative x. Or negative 1 times 7, we get negative 7. So if we write this out, we get negative x minus 7, and the 11x is still there. It's still positive, so we get plus 11x. And we can combine our like terms. Negative x plus 11x gives us 10x minus 7. Here we have a negative 2 outside of our box, and we're going to put x plus 4 on top. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. So we get negative 2x minus 8. Here we are looking for our like terms, which are 7 and negative 8. So we can combine those two. So we just have 2w, and 7 minus 8, well, that gives us negative 1. So 2w minus 1. On to our last slide. We have a distributive property problem, because we have a negative 3y up front and a 5 minus y on top. In our dotted box, we have an 8y. So negative 3y times 5, that gives us negative 15y. And negative 3y times negative y gives us positive 3y squared. So we got a couple like terms. We can combine our 15y and our 8y. But we can't combine the y squared because that doesn't have just a single y. So negative 15 plus 8y, that gives us negative 7y plus 3y squared. Here it looks like we have to draw two boxes. One here with a 5 in front, and 6 plus n. 5 times 6 is 30. 5 times n is 5n. Minus our other box, which is 2 and n minus 2. So negative 2 times n is negative 2n, and negative 2 times negative 2 is positive 4. So our new equation, our expression looks like this. 30 plus 5n, because it's positive, minus 2n comes from here, plus 4 that comes from here. We have some like terms, so we can combine our like terms. 5n minus 2n gives us 3n. And the last like term is 30 and 4. So that gives us 30 plus 4, which is 34. So our answer is 3n plus 34. Now these last two I want you guys to try on your own. Once you get done with those, you can move on to your homework. This homework is in the book. It's page 99, numbers 5 through 39. I want you to do the odds, 5 through 39 odds, and then 40 through 42. If you want to, at the end, you can check B-O-B or Bob or the back of the book for the odd answers. Take out your lined paper, write your name, hour, and assignment name. This assignment is going to be 2.5A, and the problem's on the top of the page. And you can begin. Have a good day, guys.